Okay, students, today we're going to be talking about two-step equations, and we're just going to kind of review what we know so far. I know two steps are technically reviewed from seventh grade, um, but it's a good refresher. So here we go. So I don't know if your teacher went over the party analogy before, but if not, this is how I generally think of two-step equations. I usually think of them as party problems. I know I have a three-step equation here, but it's because this equation has every member of the party in it. So when we talk about two-step equations, it's we always talk about the variable being the host of the party. So we have a party here, right? Now, if the host is in the party, that's his house, right? So he doesn't leave at the end of the night. He just gets stuck with all the cleaning. So he's the last one remaining because our goal with the equation is always to get the variable all by itself, right? Now, there are three types of guests at a party. We have our best friend, or BFF. This person just hangs out with the host, right? He's the last one to leave. He's there hanging out. He's basically there to hang out with the host, right? The other type of person is an acquaintance. Okay, they kind of know the host, but not super well. So they're hanging out, but it's, they're okay leaving a bit earlier than like the best friend, right? It's not really their party. It's more for the host and the best friend. And then we got this dude right here, which I always refer to as the creeper. Okay, he's some dude that just goes downstairs and hangs out in the basement by himself the whole party. Now, there are two types of people that might be down here. We might have a creeper or we might have a creepy best friend, and I'll get to that in a second. But the creeper has to be under the entire party. So there has to be an acquaintance up here, and he has to be underneath the host and the acquaintance in order for him to be a creeper. If he's just under the host, he's a best friend still. Okay? So the reason I talk about this is because there's an order that makes sense when you're moving things away from the variable. Okay? This creeper is going to be the first one to go. He's not really there for the party. He's there because it was the creeper is the one that is there. He's there because he went to the wrong party or something. So he's the first one to go. Then the acquaintance would be the next one to leave. So the person that's adding or subtracting would be the next one to leave. And then the best friend, the one that's multiplying here, he's the last one to leave. Okay? So that's why we use this analogy. So this creeper would be the first one to leave. He's dividing. So the first thing you would do is multiply each side by 2 to get rid of your creeper. That would leave 3x plus 5 is equal to 20. Now it's an actual two-step equation, right? The acquaintance is going to leave by subtracting him out the door because he's adding, so you subtract. That leaves you with 3x is equal to 15. And then your last step is for the best friend to leave by dividing him out the door, and x is equal to 5. Okay? So your host is all by himself. That's it. Now, one issue that students have is figuring out, well, what's the difference between this and something like this? Okay? Well, this guy is just hanging out with the host. So this is what I call a creepy best friend. He went downstairs for a second to get something from the host, but he's going to be right back up, right? So he's still just hanging out with the host. The difference is the creeper's under the entire party. This guy's just underneath the host. And the reason we do this is because every time you multiply or divide, you're technically doing it to the entire side of the equation. So if there's still another term right here, when you get rid of this guy, that 5 would have to multiply with this 2 as well as the 7. That's why we try to get like this side all to one number before we multiply. We can do it here because when we multiply, since both of these are being divided by 2, it would cancel out the 2 in both instances. That's why we get rid of the creeper first in this situation. Okay, but in this situation, the acquaintance is actually going to be the first one to leave by adding 2, which leaves you with x over 5 is equal to 9. And then we would multiply by the 5. And my lights just went out. There we go. You love it when you gotta wave your arms. And x is going to equal 45. And that would be your answer. Okay, so that's kind of how you solve two-step equations. Now, on this assignment, there's also a bunch of word problems. So let's look at an example of some word problems. I know you guys already went over this, but this is a review day. We're just going to review everything, right? So let's do one of these, and I'm going to show you guys how to make it into an equation. That's usually what makes more sense to me. But again, if you just show your work on how you got to your answer, that's all that's really needed. You're going to do the same work either way. Like, honestly, whenever I look at somebody's work and match it to what you have to do to the equation, like, it's the same work. So let's look at this problem right here. So 392 students went on a field trip. 7 buses were filled and 14 students traveled in cars. How many students were in each bus? Now, again, with word problems, it's best to go through and identify the critical pieces of information first. So first thing I know is 392 students in total went on the field trip. There were 7 buses that were filled, and 14 students traveled in cars. Okay, and then it wants to know how many students were in each bus. So how many were in each bus? So again, I'm assuming that each bus had the same amount. It doesn't say that, but let's assume when it isn't clear. So let's see how I set this up. So how many students were in each bus? So basically the bus number of students is my unknown, right? So I don't know how many students are in each bus. That's my x. I know there were 7 buses, so 7 times that number would be how many were on the buses, right? I know 392 students in total went on the field trip, and there were an additional 14 students that weren't on the buses that traveled in cars, so plus 14 would equal the 392. Hey, look, there's a two-step equation, right? Then to solve it, I would have to take away the car kids first, right, by subtracting 14, which would leave me 7 times the buses equals, I'm not thinking clearly, 378. 378. And then you would divide that by the number of buses. So divide that by 7. And each bus had 54 students. It's a lot of students on the buses. Okay, so not too tough, right? Again, if I were to do that without doing the equation, the first thing I would do is subtract the 14 from the 392 and then divide by the total number of buses. Hey, that's the same math steps that I did there, right? So not any different than just doing your work on your own, although this will help you a little bit when you get to more complicated word problems. If you're adept at setting up those equations, it helps you in the long run to build that skill. Let's do one more. Got a little bit more time left. So Crystal bought 6 CDs. A week later, half of all her CDs were destroyed. There are now only 17 CDs left. How many did she start with? So we want to know how much she started with. So that's my unknown. I know the first thing she did was buy 6. So she added 6 to her original amount. And then half of them were destroyed. So she took away half. That is dividing by 2, right? When you half something. And then we are left with 17 CDs left. So there's my two-step equation. So the first thing I want to do is I want to undo that half that were destroyed by multiplying or doubling the 17, right? So divide or times by 2. Get x plus 6 is equal to 34, right? Yeah, 34. And then I need to get rid of those 6 that she bought by subtracting those 6 from her total to get her original total, which was 28 CDs. And notice how I always put it in terms of what the question is asking for. So I don't just want like x equals. I want that answer, the actual question. How many did she start with? She started with 28 CDs. She didn't start with 28, she started with 28 CDs. So be descriptive with word problems when you know what it's looking for. And that should do it for two-step equations.